Hello everyone and welcome to this week's PROG1198 tutorial video. Our topic this week is TSQL programming. So some of the topics that we're going to cover in this video include working with variables, coding and using decision structures, and then we're going to look again at some different ways to format output. The formatting is something that we have covered before, but I've had a couple people asking me about it recently. So I think it might be a good idea to just do some more examples of how to format some of the output that we're going to be generating. So we'll start by working with variables. In TSQL, a variable must be declared before it is used. It's similar to a lot of strongly typed programming languages in that way. When you declare a variable, it doesn't persist in memory beyond the completion of the script. So what this means is, if your script makes use of a variable and you're executing that script, you also have to make sure that you execute the statement that declares the variable every time. So you can't do it in pieces, those need to happen together. When we're coming up with a name for a variable, you should know that variables in TSQL begin with the @ symbol. Sometimes you'll see the double @ sign, like we've seen in a couple previous lessons when we were using system variables. So system variables use the double @ sign, but variables that we declare begin with the @ symbol. Like all other parts of TSQL, the variable names are not case sensitive. However, you should be consistent when you're defining the names of your variables. They cannot include spaces or special characters, and you might want to stay away from reserved words. It's not a good idea to name your variable things like create or go. One thing to remember when you're declaring a variable is that you'll also need to include the data type. So TSQL is a strongly typed language. When we declare a variable, we also need to declare its data types. We're familiar with various types of data. It's the same data types that we would use when we were writing a table create statement and we're defining the types of fields or column that we're going to have in our table. All those same data types apply to variables, including the sizes. So if you're declaring something like varchar, for example, if you have a varchar variable, you need to include the length as well. So here's an example of using some simple variables to perform a calculation. Now in this example, you'll notice that we're not referring to any SQL object. So there are no database objects involved here. On the next example, we will be using variables with database objects. But just for this first introduction to variables, we're declaring and defining variables that can work independently of any database table or method. So our first statement is a declare statement. The word declare is required when we're going to call into existence any variable name. So before using that variable, it has to be created in a declare statement. We start off with the word declare. We give our variable a name that begins with the @ symbol, and then we include the data type. So the variable that I've declared here is called product, and it's a data type varchar with the length of 25. In the next example, I'm declaring two more variables. So you can declare variables more than one at a time, but you have to remember to provide a data type for each. So in this example, you'll see I'm declaring two variables, subtotal, that has a data type of decimal with a size of 6,2, and then we include the comma when we want to move on to declaring a second variable. So you can write one declare statement that declares and creates multiple variables at the same time. In the third example, we have another declare statement, and we're also performing an assignment. So the assignment, just like in regular C# programming or JavaScript or any other of the languages that you've learned, we perform assignment using the equals symbol. In this case, I've declared a variable called tax, and I'm assigning the value decimal 13 as the value for tax. The other three variables, product, subtotal, and total, do not have any values assigned to them yet. Now, If we want to assign a value to a variable, there are two different ways that we can do it. One is by assigning a literal or the result of a calculation, and the other is to retrieve and assign a value that comes from a database object, such as a table. Now, I mentioned in this example, we're not going to be retrieving data from any database objects or tables, so we're going to use a keyword called set to assign either a literal or a calculation result into each of those three variables that are as yet unassigned. So product, subtotal, and total. They all don't have a value yet. In my first statement, my set statement assigns the literal varchar value detergent to the product variable. My second statement assigns a literal numeric value to the subtotal. And the third statement assigns the result of a calculation. So we have to perform the calculation first to calculate the value, and then we're going to assign the result of that calculation into the total variable. So what is the outcome of the calculation here? Well, it says that we're going to multiply the subtotal, that's 10, times the tax value, that's 0.13. That gives us the value of 1.3. And then we're adding that to the existing subtotal. So the subtotal, 10, plus 1.3. The total data type, however, brings us 2 points after the decimal place. That's the scale, is 2 there. So that means that it's not going to be 11.3, it's going to be 11.30. So after these set statements, all 4 of my variables contain their values. When we want to see the containment value inside a variable, we have a few different options of ways that we can get the variable's values to display on the screen for us. One of those is to use our variable in a select statement. The other is to use it in a print statement. A select statement creates a data set and it shows in the grid output in SQL Server. If you use a print statement, it does not create a data set. Instead, it sends a text output message to the messages pane, the same location where an error message would go. In this case, my select statement uses concat to concatenate the variable, a literal string, and another variable under the name result. So the variable product, that was the word detergent there, plus cost, and then the total at the end, which was 11.30. You can see the outcome up here, where I get a data set with 1 row and 1 column generated from the results of concatenating the product with a string and then the output of the total variable. I'm going to put this code into SQL Server and we'll see the outcome. Here we go. Now when I want to execute this, keep in mind that if I try to execute just these lines down here, I'm going to get an error message saying that these variables don't exist. If I'm going to use these variables, I'll need to also execute the declare statements that declare them in memory. If I execute just this highlighted portion, and then later I come to execute the select statement won't be able to reference product or total because their lifespans are only during the execution of the script. After the script is done executing, variables are no longer accessible. So in order for this to work, I'll have to execute it all together. And when I do, you can see the result showing up here at the bottom with that select outputting the result. Now if I change this to print and execute the same sequence of code again, you'll notice that it causes an error over here because of the alias. I'm not getting a data set, so I don't have a column to name. I can get rid of that alias for the column header, and I just want to print out the text part of that message. So you can see how it comes out in the messages pane now. Now let's look at our next example. What happens when the data we want to work with comes from a table or another database object? In that case, we can use assignment in a select statement to assign the value of the variable instead of using a set statement. So we know that we can use select statements to retrieve values from tables. If we want then to store those values in a variable, we add the assignment statement as part of the select statement. So if we see what's happening here, we're selecting the employee salary and we're also assigning it to this variable. Now the variable is declared here. If you're retrieving values from a table, you have to make sure that the variable that you're assigning it to has the same data type and an adequate size so that it's big enough to hold it. The way that this works is that we've declared a salary variable and we've assigned its value as the employee salary that's returned from this particular select statement. Now, one trick to this that you have to remember is that simple variables in TSQL can only hold one value at a time. These are scalar variables. That's what it means. It means one single value. So if I were to write a select statement that selected all of the different employee salaries, I wouldn't be able to assign them accurately into the salary variable because there are 8 employees and it wouldn't know which salary value to assign. And what would happen actually is that the assignment statement would happen 8 times. But we all know what happens when you assign the same variable 8 different values. It's just the very last value that has overwritten the previous ones. So in this case, it's very important to write a very specific where line where you can be sure that you're only going to get one record. And now this one actually isn't great because we could have multiple employees with the same first and last name. So most of the time, your where line would include a reference to either the primary key or another business key. So once we've pulled out Vera Bartlett's salary and assigned it to the variable, you'll notice that I'm now using a set statement on that same variable to assign it a new value. So just like any other typical variable, you can assign it new values all the time. In this case, we're taking its existing value, multiplying it by a literal here, and then the result of that calculation is going to be assigned back into the existing variable. Let's put this into our SQL Server and we'll take a look at the outcome. Here we go, I've pasted the code in. I also wrote a use statement here. We want to make sure that we're using the correct database before we go to that employee table. So it's always a good idea to include a use statement at the top of your script. So if I'm to execute this now, we're going to retrieve Vera's salary. We're going to give her a 5% raise, and then we're going to show her new salary. And the new salary is $63,000. Now, there's one other thing that I want to point out. If your select statement includes an assignment, then it can't also include producing a data set to the results pane. So what I mean by that is we know that if I execute a typical select statement, its output goes down here. And now we also know that if we put an assignment statement, if I execute this assignment statement on its own, all I get is a verification that it worked. So the employee salary is no longer displayed to us. Instead, it went into the variable. And the thing about running a select statement is that you can't do both at the same time. So if you're performing an assignment, You can't also say, oh, by the way, also show me the employee first name, because it'll give you a message here. A select statement that assigns a value to a variable is not combined with data retrieval options. So you can do one or the other, but you can't do both at the same time. You can, however, do multiple assignment statements in the same select. So if we wanted to, for example, declare a name and store the name of this person, I can do two assignments in the same select statement. And I can prove that both assignments work by putting them both into this select statement at the end. So let's give this a shot. You'll see how I've assigned and calculated both values of those variables that were retrieved from the employee table. So variables are pretty useful. Now, if I execute this thing without the where line, we'll see what happens next. The values that we get are the ones for Ned. Ned is the last employee in the list. If I select all employees, and we take a look at the output, you see that it will have done the calculations for the other 7 people, but it's overwriting the salary and the name each time. So because this happens for every employee now without the where line, salary is going to have its value assigned to 8 times, and name is going to have its value assigned to 8 times. So the where line is really, really important. Even if it is the last employee that you do want, you still don't want to be performing all of those assignment statements. It's not so bad if you only have 8 employees, but if you had 80,000 employees, it would really, really negatively impact the length of your execution time of the script. So this is, a decent, but what would be better is that. All right, let's move on. Now, another really important use of variables is to parameterize queries. And we'll see this and the use of this later on in the course when we get to our client-side application, because it's a really useful way to perform a search using the like operator. So in the first lab, we used the like operator, and this example uses it as well with the wildcards so that we can find approximate or partial matches. Now, in this case, we want to write a query that returns custom results based on the value of a variable. So let's say, for example, we wanted to be able to search by employee names, first names. And we know that we need to write a select statement to show us all the employees. And if we look at the where line here, the where line says where emp first is like, and we have the % symbols that are the wildcards. But in the middle, we have a variable. Now, currently, this variable's value is set to the letter R. So our query is going to boil down to select all from employee, where employee first is like, % R, %. Now, if I put a query like that into my code, we can find a list of employees who have names that contain an R. And then later, if I change my mind and I'm actually looking for employees' names who have a T, you can see how I need to change what's in my pattern. So what we do is we can create a generic query that replaces this changeable value with a variable. Now, if we want it to be taken as a variable and not literally an employee who has their name is emp name, then we need to indicate that this is a string and this is a string, and we're concatenating them together. Then our emp name variable, once we declare it, whatever it contains will be replaced into the middle of the like statement. So what is this going to be used for? Well, when we make our client, we'll be able to make a search box, and they can type whatever they want. We don't know what they're going to search for, but whatever it is, we're going to capture it in a variable and put it into this query. In order for the variable to be used, it needs to be declared and it needs to be set. So here's the declare statement and the set statement. Currently sets it to the value r here, but once we start putting things like this into things like user-defined functions or attaching it to a client, the value of this would come from somewhere else, either from an input parameter in a function or from like a text box or something like that on a client-side application. So once I execute all of this, you can see how the parameter is being filled in. And it doesn't just have to be one letter. I can look for, let's look for something that's actually in there though. RA, for example, and we can find employees whose names match the query that we're looking for. So doing a parameterized query is a very, very common thing to do. And once we get into writing procedures for client-side use, you'll notice that almost all of our queries are going to be fully parameterized so that they can be dynamic instead of hard-coding what we're looking for or hard-coding what we're trying to do, say in an update statement or a delete statement. We're going to just use a parameter for that. And we'll see further examples of that as we move through the future of the course. All right. Our next topic is decision structures. And we're going to look first at an if-else statement. So we use if to perform conditional logic. You can use if along with else to choose between two outcomes, or you can use multiple else-if blocks to choose between many options. So the syntax to this is really similar to other programming languages. But one thing you'll notice is that in TSQL, we do not have brace brackets. So, in C#, we have these guys that enclose our code blocks when there's more than one line of code. We don't have those in TSQL. So we're going to need another way to enclose blocks of code. Now, if the code block only contains one line, then we don't need any brackets or any way to enclose it. And that's what this example shows. So the if statement here has multiple branches that evaluates this variable called temperature. So the temperature here is being set to 12. You can see I've declared the variable, set its value, and then I'm going to evaluate its value in this series of if-else statements. Now, I've set it to 12 just for the demonstration, but obviously it could be any integer. The other thing I've done to set up is declare another variable of varchar called weather. So we're going to assign a value to weather based on the temperature. So in TSQL, we have comparison operators. We've seen them before in where logic, but now we can see how they're also used with variables in an if-else situation. So we have all the same comparison operators, less than or equal to, greater than or equal to. We have equals, which is just one single equal statement. And we also have not equals, which can be written two ways, either the exclamation point equal or the less than, greater than together. We can also use any of the other operators that we're familiar with, like, in, or between. So this particular example says if the value of temperature is less than 0, we're going to assign freezing to weather. If not, we move on to the else. The else says if the temperature is below 10, set weather to cold. Now, just like other languages, if-else sequences like this are mutually exclusive. So if you enter one of them, the rest of them are all skipped over. And we have 5 different outcomes here. So we have freezing, cold, mild, warm, or hot. By the time we get to the end, you'll see that the final else does not require a condition. This is what happens if none of the other ones evaluate to true. Then at the end, we can see what the weather is. And because the temperature was 12, well, it's not less than 0, so we go to the else. It's not less than 10, so we'd go to the else. It is, though, less than 20, so we end up here and then skipping over the rest of them down to the print statement. Now we see the print statement says the weather is mild. So if-else is pretty straightforward. Now I do want to show an example of what happens if there are multiple codes, lines of code in the if or else block. So I'm just going to bring up my SQL window. And I'm going to start by typing the code for our if statement. And then I'm going to add a few extra lines. So I'm going to declare another variable. And we'll call this one coat, whether we're going to wear a coat or not. And let's call it char1. So 1 character here, indicating yes or no, whether we want to wear a coat or not. So if the temperature is less than 0, the weather is freezing, and we're going to set coat to yes. But you'll see now it's introduced an error because my if block has gone to this first set as the conditional statement, and even though I've typed this in a visual way that makes it look like both set blocks are part of the if, this set block is not part of the if. So then, no matter what the temperature is, we're always going to set coat to y, and then we encounter an else that didn't begin with an if statement. So how do we group these together? It's not by putting them in the same tab order. White space is meaningless in SQL. We just put it there so that programmers can read our code. What we would do if we were in C# is this. But, of course, we don't have brackets in TSQL. So what do? Well, we replace the opening bracket with begin, and the closing bracket is the word and. So begin and end, enclose the code block that makes up the entire if statement. So if you have more than one line of code that is operating in the condition, you need to enclose it with begin and end, which act like those brackets to group the code together. Let's look at another decision structure. The case statement is a very popular one. Case statements are kind of similar to switch statements. And you'll notice the same type of keyword, but we use it a little bit differently. In C# we would have switch and then list a bunch of cases. In TSQL, though, it starts with case, and then we list a bunch of whens. So the case statement is going to evaluate one condition at a time and returns a given value when it encounters a true condition. If none of the conditions are true, then we use else, which is like the default outcome. And if there is no else statement, if there is no default outcome, then the value of null is used as the outcome. So let's take a look at the use of case in a select statement. We're selecting from employee, and it starts off pretty straightforward. We're selecting the first name, last name, title, and salary of employees. But after that, we're selecting what essentially is a calculated column or a calculated field where we are determining what to select based on the outcome of this case statement. Now, before I put this in here, I'm going to start with the typical select statement that doesn't include the case. So we're going to select everything from the employee as a starting point. So here's our employee list. And what I'm trying to create here is an indication of whether the salary is low, mid-range, or high based on some criteria that I have defined. So we know that we can select literals into our outcome. For example, if I select hello as part of my select statement, you'll see that I get a bunch of hellos in here. But instead of just selecting the same thing for everyone, I want to make an evaluation. If the salary is low, then I'm going to write entry-level salary. And if it's like a medium range, then we're going to say medium. And otherwise, we're going to say high. So anybody less than $50,000 salary is going to be entry-level. Now, if that isn't true, then we're going to go to the second one. It'll evaluate and return medium if the employee's salary is less than $80,000. But of course, $50,000 or above. If it was less than, it would have gotten here. So we have these three possible outcomes. So let's put that into our statement. So when the employee salary is less than $50,000, and we use then to indicate what it should return. So what it's returning is the thing that comes after the then statement. And it's going to be one of the three possibilities. The final statement, else, executes if neither of these when statements are true. And you can have as many when statements as you want. Now, you'll notice incorrect syntax here. The reason why we have incorrect syntax is because I have not ended my case statement. Just like any code block, we need to denote where it begins and ends. Now, in this case, we don't need a begin statement because case serves that function for us. However, we do need an end statement. And you might be thinking, well, why doesn't the else serve that function for us? And the reason is because we know that the else is optional, right? There's an option where there could be no else statement. So that means we need to be able to tell the system when the case is finished, and we do that with an end. So just like begin and end for multiple code blocks, if you have a case statement, you have to end the case statement. All right, let's test this out. So we can see it evaluating and returning different values for each of the employees. Here's an entry level less than 50,000. Here's a medium that's less than 80,000. And the high is not either of those other two, the default value. Notice we don't have a column name here. Having a column name is really important, especially once we move into working with the client operation. We need to be able to access this column, and if it doesn't have a name, then the only way to access it would be through its numeric index. So we want to give this column a name. This is the end of the statement that generates the column. So this is where I'm going to put my alias. Now we can execute this, and we can get a dynamic pay level for each employee. Now you don't have to put a case statement in a select. You can do it with a set as well. But I wanted to show you this in particular, that you actually can use it in a select statement. So there's two different ways to make conditional outcomes in TSQL, through if statements with else's or through case statements. And the syntax to this is a little bit different than what we're used to, but I think it's pretty self-explanatory. You start with when, you have some kind of comparison, same comparison operators that we've always used, and you have then with the outcome. Let's move on to formatting. So we're going to look at two different formatting functions here. The first one being format, the second one being coalesce. So format is for numbers and dates. If you want to format a number or a date as a particular style or to look a particular way, we can use format for that. So the format function has three parameters. The first one is the value that you're formatting. Now this could be a literal value, it could be a variable, or it could be a value that is a database table column name. The second parameter is the pattern, or we call that the format string. And there's two different ways to construct a format string. One of them is to use some of the predefined default ones, and I've chosen that here. I've used C, which is shorthand for formatting currency. The other way is to write your own format string indicating where you want the pieces of data to go and how you want them to be formatted. The third parameter, which I've left out of this first example but shown in the other two, is the culture. If you leave out the culture, it uses the one to your local server. But in this case, I've shown you two different examples of cultures. This one's French, Canadian French. This one's British English. Most of our computers are probably either set, to a local from wherever you purchased your computer to, or from wherever you're currently residing. I'm using the same value and the same pattern each time, but you'll notice how changing the culture changes the outcome. So this first example, my current computer culture is set to English Canadian, so it shows this value as currency in a Canadian format with a $sign and a decimal point. Same value, but currency in French, they formatted a little differently. And same value, currency in Great Britain, you can see there's the pounds instead of the $sign. Now I've put a link on this slide. You might want to click on to give you some more examples of using format. Using format is very common when we want to do date displays. I'm going to get my pointer back here so I can click on this and we'll take a look. So the Microsoft documentation shows us some formatting example with dates in different cultures. The results come out down here. Notably, the difference between US English and Great Britain English. We have different order of days and months. You can use lowercase d to show a short date, we call that. Or you can use uppercase D to show a long date, which includes the day of the week and the name of the month. If you want to create your own custom formatting string, there are all different kinds of custom formatting codes that you can use for dates and for numbers. And for more information on knowing exactly what those are, you can click on this link here. Now the last example I want to show is an example of using coalesce. Now coalesce is a way that we format strings. Now we have a few different ways of formatting strings. I showed you concat previously. We also have the simplest way of just using the plus sign to concatenate strings together. But the coalesce function is unique in that it can evaluate several different inputs and return the first non-null input it finds. Coalesce can be used in place of case statements when all the case statements are evaluating expressions for null. So if you have a certain situation where you're saying, if the company name is there, show that. But if the company name is empty, then show the customer name. And if the customer name is empty, then show unknown. If you have a list of outcomes where you're all looking for things that may or may not be null, then this is when you want to use coalesce. So in this example, we're using coalesce on a field called company name first. And then second, we're using a field that concatenates the first name, a space, and a last name. So we have two possible outcomes here for coalesce. But if the company name is not null, then we're going to use the company name and ignore the second option. If the company name is null, then we're going to bypass the null and build the second option. Both of those are used, either one or the other, as a field called customer. So let's take a look at how this turns out. This is the same statement. I switched tables just to show us some examples of customers. This one is using that sports database that we have. So on the left, this is selecting the customer's first name, last name, company name, and ID. So you can see that some of the customers have a null in place of company names, and some of them don't. We want to create a field called customer where we can address it to the company if there is one, and to the individual if there isn't. So we can see how that coalesce uses the company name when it is there, but when the company name is null, it uses the person's first and last name instead. So it's a bit of a niche market using coalesce, but it does have an important place in building nice looking and robust output. Now on our last slide, I want to demonstrate something that we can do with a case statement called selecting from subquery. Now you don't need a case statement, but I think this really well illustrates what we can do when we combine all of our knowledge together. So we know how to do subqueries, and we know now how to do case statements to generate some extra values. But let's consider this here. I'm going to execute this again so we can make sure we've got the most up-to-date outcomes. Now, here's my list of employees and all of their pay levels. What if I just want to show a list of employees who are making entry-level pay, or medium or high? I think, okay, well, I've got my data set. I'm going to add a where line, where pay level equals medium, for example. But you'll notice that even though I have this pay level column, I don't have it in my where line. It's because pay level isn't a column. It's an alias for a block of code, essentially. So I can't refer to it in my where line. Now, one thing that I could do to obtain this outcome is figure out which case I'm interested in and write a where line where pay level is greater than or equal to 50,000 and, excuse me, not pay level, emp salary. And also emp salary is less than 80,000. This works, but it's not a great solution for two reasons. First of all, if I change my case statement, say I want to redefine what entry level means, now I have to change this in two places, here and there. It's terrible for maintenance. The second thing is redundancy. I'm wasting valuable space coding the same thing twice. So we don't want to do this, even though this will give us the desired outcome this time. It's not a great plan for those reasons that I mentioned. What I really want to do is say where pay level equals, whichever one we're interested in looking at. Now, in order for this case statement to be taken as part of the actual data set, if I execute this on its own, without the where line, we see how we get a data set. Now this data set is the one that I want to query. So I have to generate this first, have a column called pay level, and then add that pay level to my where. So the select statement that builds this data set needs to be executed in a subquery before I can refer to pay level in the main query. The subquery in this case is not being done in the where line. The subquery is generating the table that I want to select from. So when I want to access pay level, I can't get it directly from employee. The only place I can get pay level from is this outcome data set. So I'm going to set that all in some brackets here to indicate that this is the subquery. And the subquery generates this, I don't want to call it a table because it doesn't persist, but it's a set of data in tabular format. If I give this thing a name, now I've called it data set in the example, but it's essentially just giving an alias to the outcome of this. And because this thing is a table, I can now select from it. Select all from this table. So if I select all from the table that's generated as part of the subquery, now my outer query looks the same because I selected everything, but my outer query has access to all of these columns as parts of the table, including pay level. You'll see the error is gone. So now I can get us a list of employees who fall into that high pay level without having to rewrite all of the case code that I already wrote once. So in this example, selecting from a subquery indicates that the subquery is going to generate a data set that looks sort of like a table. We're going to give it a name, and that name, it's just like giving an alias to a table. That table will have all of these columns, including the one that we defined as pay level. All right, so that's the end of this week's TSQL video. I hope you guys enjoyed it and that you learned a lot, and I will see you next time.